Okay, so this is going to be a short little video on finding the area of a triangle using the determinant. Now, remember, determinants are only with square matrices, so we have to make our triangle vertices into a square matrix. Now, we are dealing only with triangles that are graphed, so we have coordinates for them. So the things we have to have for this are going to be our three vertices. So let's look at our notes for this. Finding the area of a triangle. All right. So when we look at these, we need to have some vertices. We also need to know how to set up the matrix that we're looking at. So we're going to have a set of three vertices. We're going to have an x1, a y1, an x2, a y2, and an x3 and a y3. So those are going to be our vertices for our triangle in a coordinate plane. Now remember, when you're finding the area of a triangle, it is always 1/2 of the base times the height. So we always have that idea of the half in there. Okay, so you're always going to end up multiplying by 1/2. And it is area. It's area. So area equals a positive answer. So no matter what you get, turn it positive every single time. We're always, always, always going to have a positive answer. Now, like I said before, we have to have a square matrix. 6 terms will not give me, or 6 entries will not give me a square matrix. So what we have to do is add a column to our matrix of a number that will never change the value of something when multiplied. And we all know that to be the magic number 1. So in general form, our formula to find the area of a triangle is 1/2 the determinant of a column of x's, x1, x2, x3, a column of y's, y1, y2, y3, and a column of 1's. And that's going to give me my not my determinant. I'll find the determinant, but it's going to give me the area of my triangle. So let's look at an example. I'm going to change color so that we know that it's different from our notes. So if we look at an example, and let's say that we have the given vertices, one, 2, 6, 2, and 4, 0. So we're going to set up, using our little formula right up here, we're going to set up our determinant. So it'll be 1/2 times. All my x's are a column, all my y's are a column, and then I have a column of 1's. So 1, 6, 4, 2, 2, 0, and then 1, 1, 1. Now we have a matrix that we can find the determinant of. And remember, when you're finding the determinant of a 3x3, we have to write those first 2 columns again. Okay, and we're going to go down our vertices, or down our diagonals, and then back up the diagonals, and we're going to end by multiplying by 0, or by 1/2. All right, so 1 times 2 times 1 is 2. 2 times 1 times 4 is 8. And 1 times 6 times 0 is 0. Okay, minus 4 times 2 times 1 will give me 8. 0 times 1 times 1 gives me 0. And 1 times 6 times 2 gives me 12. Okay, so now when I add these together, I'm going to get 10 minus 20, and 10 minus 20 is a negative 10. Don't forget about this 1/2 out here. So now I have 1/2 times negative 10, which gives me a negative 5, but what do we know about the area? Area always, always, always has to be positive, so it's 5 units. So we must be positive. And that is how we find, you let me forget the square, 5 units squared. And that is how we find the area of a triangle. So this goes with the 3 problems in your homework, page number 16, 17, and 18. Okay, so that's how you will work those 3. Talk to you later. Bye.